All right, everybody, on to round three of our videos covering the law of cosines. This is going to be the application section. Applications they always show up, and really navigation is where we tend to use a lot of triangles where you have two distinct points, and at some point you have to check in to see where you're at supposedly along that path. If you're off path, you have to check how are you going to get yourself back on path. So in our first scenario, problem number three, you're in a boat leaving Naples, Florida, and you're traveling at a speed of 15 miles per hour to Key West, which we know is 150 miles away. Now, after 4 hours, we realize that we are 20 degrees off course, probably something like we didn't take the tide into consideration. So we are 20 degrees off course. And it's very helpful that we have this nice drawing right here just so that we can get an idea of what's going on. So the first question that I have is, how far is the boat from Key West at this point? So how far is the boat at Key West? Let me take a look and see what I have. I know that I've gone 60 miles, and the reason that why I know that I've gone 60 miles is because if you take 15 times 4, 50 miles per hour after 4 hours, we're 60 miles away. We also know that we are 20 degrees off course, and we knew that Key West was 150 miles away. So when I take a look at what parts of this triangle do I have, so I know how to solve this, I have a side angle side relationship. So I always like to identify what kind of relationship I have because that tells me what approach do I need to take. And surprise, surprise, we need to use the law of cosines in order to solve this. So with the law of cosines, let me go ahead and rewrite just because it's been that minute since we've used the law of cosines, or if you've been watching it, it's been roughly 5 minutes. So law of cosines, I want to know how far away I'm at, so that would be x. Let's go ahead and label, we know that that's angle A, so let's call this side A. We know that that 20 degrees is, I guess it doesn't matter what we label it as. So let's go ahead and just use the law of cosines. We know that our goal is to find x squared. Let me label this as part A. Our goal is to find x squared. This is where we don't have any A's, B's, and C's. We can go ahead and identify it. It can be helpful. Or let's use the idea of the law of cosines, which would be the unknown side is going to be the other two sides squared. So 60 squared plus 150 squared minus 2 times those two multiplied. That's 60 times 150. And then cosine of the included angle. And I say that as this is the main idea behind the law of cosines, that one side squared or the other two sides squared is added minus the product of, or twice the product of those two sides and then the included angle. So in our calculator, let's go ahead and plug all that information in. So if I do 60 squared plus 150 squared minus 2 times 60 times 150, and then times the cosine of 20 degrees. That would be that value, which unfortunately that's not exact, but that's okay because in order for me to find the unknown side, I still need to take the square root of it. So let's go ahead and do the square root of that answer. Let me throw the decimal in here just so we get the decimal. And so it looks like we are 95.8412 miles away. So 95.8412 miles. All right. Let me write that down here, 95.8412 miles. All right, part B. Part B asks us, what angle should you turn to correct your course? So the angle that I'm trying to turn is going to be this theta. In order for me to find that theta, really I'm being asked to, let's solve the triangle. So I could use the law of cosines on this, or now that I know that other side, I could use the law of sines. If I use the law of sines, I will have a side angle triangle. If I have a side-side angle, there is some ambiguity there. Now, with this ambiguity, we could see by our drawing that 150 degrees is open the largest angle. So if I use the law of sines to find angle A, which means angle theta as well, I'm probably going to have to take the obtuse angle on this one. Now, this is where ambiguity comes in. At this point, you know what? Maybe I don't feel quite so comfortable in using the law of sines on this, because what happens if I get an angle that's somewhere around 90 degrees? I don't know. So let's go ahead and use the law of cosines. So to use the law of cosines, this would be the cosine of angle A. And if you remember with the law of cosines, let me go back to this form of it. With the law of cosines, we are going to be taking the other two sides squared, add them together, and subtract the side opposite of the angle that I'm trying to find. So at this point, let me go ahead and just rewrite it. So the cosine of A is going to be b squared plus c squared minus a squared over 2bc. Now I realize those variables don't match up. That's okay. Cosine of A is going to be the other two sides that I want, which would be the 60 squared plus that 95.8412 squared. In my calculator, I'm going to be using the exact answer, minus the 150 squared, all over 2 times 60 times the 95.8412. All right, into the calculator. I'm going to go ahead and do this all as one big fraction, save myself a little time, save yourself a little time too. So the inverse cosine of 60 squared, and then plus, I'm going to hit that squared, minus 150 squared, all over 2 times 60 times, now if I scroll up, it might not hit it exactly, so let me do 95.841185.436, that should be enough. And that gives me 147.636 degree angle. 147.636 degree angle. Now, this is good that I actually use the law of cosines. As I said, the picture kind of pointed out that it's probably going to have an obtuse angle. The law of cosines guaranteed that's what I should have. Now, that angle is this angle that forms part of the triangle. Now, keep in mind, though, that I'm going to scroll in right here. The boat is actually traveling in this direction. So in order to figure out what angle I need to turn, I'm going to have to take the supplement of the angle that I just found in order to say what angle do I need to turn. So 180 minus that 147.636 gives me 32.364 degrees. 32.364 degrees. That is the angle that I need to turn. And then last but not least, if we still maintain a speed of 50 miles per hour, how much longer will the trip take than it was intended to? So first thing that I need to do, and I'm going to go ahead and change colors just so I can see it a little bit differently. What was the trip intended to take? So the distance is 150. And if you remember, time equals that distance divided by the rate. So time would equal that 150 over the rate, which was 15. So it was originally supposed to be 10 hours, a nice even 10 hours. But since we were 20 degrees off course, now we're going to have to take and say, what is the time in order to go from our current location to Key West? So it's going to be that distance of the 95.8412 and divided by that speed or that rate of 15 miles per hour, Let me go ahead and do this in the calculator. That divided by 15 gives me 6.389. 6.389, and our units are still hours. And if we add that to the 4 hours that we originally traveled, this gives us 10.389 hours. So that 10.389 hours, how much longer? So to answer, 0.389 hours longer. All right. Should we take this to minutes and seconds if we wanted? Yes, we could, but we already did that practice in the last video. So let's go ahead and move on to problem number 4. To approximate the width of a lake, surveyor starts at one end of the lake and walks 245 yards and then heads back to that original point and then walks 270 yards until it arrives at the other end of the lake. And our goal is to say approximately how long is this side. And if you see what kind of triangle do we have a side, the included angle, and side. So side angle, side triangle tells me, boom, law of cosines. What is that included angle in between? 70 degrees. So this one is going to be a fairly straightforward problem to say, in order for us to find x squared, that would be the other two sides squared, 245 squared plus 270 squared, minus 2 times 245 times 270, cosine of 70 degrees. Throw that in the calculator. So 245 squared plus 270 squared minus 2 times 245 times 270, cosine of 70 degrees. And let's make sure we put a decimal point in there so it gives us a decimal answer. So x squared will end up equaling that 800 or 87,675.7-ish. It's actually a little bit more than that. What I want to do is let's find the square root of that. Hopefully common sense would say something tells me that it's not 87,000 miles across, but the square root of that answer is 296.101. I'd like to fill this in a little bit more to say 3.5. So x ends up being 296.101. So I like this problem. It was definitely a little bit more straightforward. One of the things that I want to highlight at this time, though, is please keep in mind that we are using cosine here. I know it's kind of rough to say, but I have had so many students in the past where they're using the law of cosines, but they throw a sine in there. Please don't ever do that. This is the law of cosines for a reason. Please use cosine. On to problem number 3. And once again, we're back talking about bearing. Bearing, I told you right from the beginning in 8.1 that bearing comes back over and over and over again, so we can't ever forget our bearings. Bad pun there. Okay, moving on. We have 2 ships which are leaving port at 4 p.m. Let's go ahead, draw our situation out. So if 2 ships are leaving port, as I go draw this out, I'm going to do north-south axis. Since we're heading east, it just helps me establish, okay, we're going to be going east. So ship A is traveling 11.5 miles per hour at 38 degrees east of north. So that's roughly a 38-degree angle right here. So 38 degrees east of north gives me that. And it's traveling at 11.5 miles per hour. That's going to be important to know. Ship B is traveling 13 miles per hour at a bearing of 47 degrees east of south. So let's draw roughly a 47-degree angle right here. 47-degree angle. And then at 7 p.m., ship A is stranded and calls for help. So we know that ship A is right here. Ship B looks like It's probably going to be a little bit further because I traveled faster. Should be right about there. So, how far did each ship travel? And this is where I'm going to take a look and say we traveled from 4 p.m. to 7 p.m. So if we multiply 11.5 times 3, 11.5 times 3 is 34.5. So ship A traveled 34.5 miles. And then 13 times 3, I think I could do that one. That's 39 miles. So my first goal is to say how far apart are they? So let's draw on the rest of this triangle. And I have two sides, but I really don't have any other information unless I go ahead and use the two bearings. If that's 38 and that's 47, we will take 180 minus 38 minus 47 to figure out that we have a 95-degree angle in between. That 95-degree angle allows us to say we have a side angle side triangle. And of course, side angle side triangles, once again, we use the law of cosines. So with our law of cosines, let's go ahead and establish our goal is to find, let's call this P for port. Our goal is to find side P. So P squared would equal the other two sides squared. So 34.5 squared plus 39 squared minus double the product of those two sides. That's 39. And the included angle, the cosine of the included angle. So the cosine of 95 degrees. Throw this all into the calculator, 34.5 squared plus 39 squared minus 2 times 34.5 times 39, and then cosine of the included angle, which is 95. So that would be P squared. So let's take the square root of that answer. So P ends up being 54.275 miles. All right, easy part is done. So that was part A, easy part's done. Now this is where the bearing's gonna kick in. If ship B travels towards ship A, what bearing should it take to get there? So what this means is I know B is traveling towards A and I need a bearing from B to A. I don't have that bearing yet, but it's going to be important for me to establish that B is now going to have an entirely new north-south axis that we're going to be working with. I know that doesn't look straight up and down, but that's okay. So we have a new north-south axis, and based off of my drawing, which possibly could be wrong, but based off of my drawing, that is the angle that I am going to need to find because that's going to give me my bearing. So how do I do this? Number one, what other pieces of information can I determine based off of my situation? What I'm going to say is our goal with this section has been solving triangles. I think it's going to be kind of important for me to know what this angle is. Now, that angle P ended up being an obtuse angle, so I'm very confident that angle B is going to be acute. So P was obtuse, so B has to be acute. So let's go ahead and use the law of sines. So the sine of angle B over its opposite side, which is 34.5, will equal the sine of P, or the sine of that 95-degree angles, over the 54.275, that number that I just got in my calculator. So that means B will be the inverse sine of 34.5 sine of 95 over 54.275. Throw that in the calculator. Inverse sine. Let's go ahead and put the fraction bar up there too, just to make life easier on us. So inverse sine of 34.5 times the sine of 95. And then we're going to divide that by 54.2751. Hopefully this will give me close enough. 39.289 degrees actually is what I got when I used the exact value, 39.289 degrees. So that's angle B. That doesn't actually tell me the bearing. So in order for me to find the bearing, I'm going to have a little kickback back to geometry. So remember what happens when you have two parallel lines cut by transversal? So I know that if this is a 47-degree angle, then by alternate interior angles, this is also a 47-degree angle. We could also use same side interior angles to say this is a 133 degrees. I prefer to let's focus on that 47 degrees because what's happening in our scenario is this part of the triangle gives us an angle right here of the 39.289 degrees. So if I want to know this remaining angle right here that I'm shading, I'm going to take 47 degrees, subtract the 39.289 degrees that I got in my calculator. So 47 minus that answer gives me 7.711. So I am going to be traveling northward 7.711 degrees, and I am going to the west. So one of the things that we just encountered for the first time, I believe, that we are going to have to establish new north-south, and we're going to have to remember some geometry of alternate interior angles, same side interior angles. You have to look at like different aspects of that geometry. So hopefully this helped you. Remember, these kind of problems are going to show up quite a bit. These bearings, you will have bearing problems, and sometimes you're going to have to think about whether it's acute or obtuse. You notice I'm mixing law of sines and law of cosines. I like to use law of sines just because it's a lot simpler, but sometimes, like I had in this problem, law of cosines, I wanted to be cautious because I figured that was going to be an obtuse angle, so the law of cosines gave me that obtuse. So I hope you enjoyed this section of the law of cosines. I really enjoyed like really all of the applications to trigonometry. It's just a lot of fun for me. But as always, I've got your back and you've got your back. Thank you very much. Have a good night.